To help you prepare for our Chapter 4 test, I thought I'd put together this review video. This chapter involved graphing linear equations, and we found out there were three methods. We started off with the table of values. Given an equation in function form, we set up a table, created our coordinates, and graphed them on the coordinate plane. But we also found out that there were two quick graph methods, one involving the x and y intercepts and the other slope-intercept form. Speaking of slope, we found out there were several ways that we could calculate slope. One was by, given a graphed line, we could then discover the ratio rise over run by counting the boxes from one point to another. The second method, which is the one we'll use the most, is the one where we use the slope formula to find the rise over run. Slopes. Yes, we talked about slopes, and slopes came in four different forms. We had our negative slope, which falls from left to right, our vertical line, which is an undefined slope. Lines that rise from left to right have a positive slope, and our horizontal line has a slope of 0. We then discussed the model of direct variation y is equal to kx, where k is some constant, and that's called the constant of variation, and we also know that that is the slope of our line. So we'll find out that x and y vary directly under certain conditions by a constant k. We also found out that when graphing, that the graph of this particular model passes through the origin. And then we talk briefly about parallel lines. But let's look at some examples of each today. As part of our review, let's talk about what constitutes a solution to an equation. I'm going to give you an ordered pair, or maybe a series of ordered pairs, and ask you which ones are solutions. And by solutions, they are points that will fall on the line. So taking our first ordered pair here, let's substitute in our 4 for x and our 2 for y. We're going to get 8 plus 2. And we're going to see that this first one creates a false statement, so this is not a solution. It's not a point that will fall on this line when the line is graphed. Second problem, let's substitute in the negative 2 for x and the 3 for y and see if this creates a true statement. And as I'm simplifying, I see that it does. So I can say that negative 2, 3 is a solution, which means it's a point on this line when graphed. Constants. This is an important topic. Not all equations are going to be graphed at a positive or negative slope. We came across the constants, which says that x in this case is always going to be a negative 3. That means that this line is a vertical line, which means it has an undefined slope. To sort of give you a picture of what this is like, if you forget which is vertical and which is horizontal, if x is always going to be constant, that means I can choose any value on this line and calculate the or state the ordered pair, and I'll see that maybe the y might be negative, might be positive 2, it might be 0, it might be negative 1. All of these points fall on this line. It's a vertical line and it has an undefined slope. If the constant equation says y is equal to 4, that means y is always equal to 4. If I again do a little bit of a sketch here and I see that I choose and notice that y is a constant, it's always going to be 4. I can pick any value here and I can see that those points are all on this line. So vertical lines have that undefined slope and horizontal lines have a 0 slope. These are the two important types of slope that will definitely be on our exam. Moving on to our next topic, finding intercepts using the quick graph method. We're going to remember that in order to find our intercepts, we'll set the opposite variable equal to 0. So let's set y to 0, which simplifies to negative 2x is equal to negative 6. And by dividing, I'm going to get x is equal to 3. This is my x-intercept. To find my y-intercept, let's now take 0 and replace that with the x. It simplifies now to an equation of 3y equals -6. One inverse operation again will give us the value of our y-intercept. We only need 2 points to graph a line, so if my x-intercept is 3 and my y-intercept is -2, I connect those points, and there's my quick graph. So quick graphs come in two methods, two different ways that we can do quick graph. The second one was with our slope-intercept form. Now the equation has to be in the right form, and this one is in standard form, so we must start by rewriting. I'm going to add 2x to both sides. That leaves me with 3y is equal to 2x minus 9. By dividing all terms by 3, I will get y is equal to 2/3 x minus 3. How do I go about graphing? Well, I'm going to identify my slope and identify my y-intercept. I always start graphing with my y-intercept, which is -3. From that point, I'll count up 2, 1, 2, and over 1, 2, 3. There's my 2 points. There's my line, and it is positive. And notice that my slope here, 2/3, is also a positive number. Those two things should match. Direct variation was another topic, and we found out that if we can use our model and replace this ordered pair, which the x and y are, the value of y was 20. We're searching for the value of k. We'll divide both sides, and we find out that our constant of variation is -5. And you should remember that that's also our slope. So what does the equation of the line look like? Well, y is equal to -5x. A rough sketch of this graph, we know that it will pass through the origin. So it'll start right there, and then I'm going to count down 1, 2, 3, 4, 5, and over 1, and connect. There's your model of direct variation and its graph. And I believe the final topic, the next to final, I should say, was calculating slope. Now, on this test, because it's a Canvas quiz, you will not be counting boxes off the coordinate plane, but you will be using your slope formula. So let's now find the change in y over the change in x, and we'll see that we get a -2 and the opposite over -2, and our slope is equal to 1. Now that we know our slope, that's all they asked us to do. The very last thing I wanted to bring up in this review session was our parallel lines. Parallel lines are those two lines that will never intersect, and we found out that their unique relationship is they have the exact same slope. And we demonstrated that with some examples last week. We want to identify our slope. It was easy in the first equation because it was in slope-intercept form. However, in the second one, we need to rewrite it. So if I'm rewriting this, I'm going to get y is equal to -3x plus 5. The slope of the second line is -3. These slopes are not the same, so these lines are not parallel. And that's pretty much my review.